Assalamualaikum and good day everyone. We are from Group 4 and we will be presenting about the final design selection of our project. My name is Lutfi Shamsufidah bin Numarif and my matric number is 21558. So I am the first presenter of this project. So this project is developed lifelong learning for children to have a basic knowledge about recycling. So as they have been fun playing with the playset, so they will also learn about how the recycle can be done. So the concept that we put in this playset, which is a crushing method.
Hello, Assalamualaikum, and a very good morning, everyone. My name is Nur Aira binti Sharon, and my matric number is 216251. So, this is the first design which I did during the individual presentation. The reason why I include this design is because it fits with the baseline recycling method that my group has chosen, which is crusher method. The design is medium in size but required a lot of manufacturing steps and processes. It is also costing a little bit of money due to that. The design was inspired by Korean amusement ride. The design works by balancing the kid's weight using the flat ball, which will sway like a boat. Also, as you can see, the design came with a seatbelt on the chair for safety measurement for the kids. The material also is safe for children with skin problems such as eczema, as it uses composite material made of leaves for the seating and the handle. So the point is to prevent children from touching rusted metal. This second design was inspired by the discussion of idea between me and my team member. The design was inspired by merry-go-round that we modify using the movement of it and uses bicycle instead. The bicycle rear tire will be connected to the crusher container so that the bicycle will move in a circle around the crusher, while the crusher will also move stationary in circle. The pedal will be connected to the crusher. Therefore, as the kid is pedaling the bicycle, the crusher will also move along with it. The bicycle also have no bike chain to prevent injury and as a safety measurement for the kids. The material used for the design is composite material, polycarbonate and steel. Also, the cost to produce this design is very cheap and affordable.
Hi, my design is a combination of bike sharing and threading. According to existing research, the human leg muscles are the most powerful. At the same time, the main moving component of the crusher is the spindle. I wondered if we could use the same force as a child pedaling by a bicycle while playing to drive the crusher. The key to the design is how to transmit power. I designed a gear train to convert the circular motion to the fixed axis rotation of the crusher spindle by means of the epicyclic gear. Considering that the child's strength may not be enough, here we go through the combination of pinion to big gear, and the lever theorem shows that the force on the pinion, that is the force provided by the child when the pedals, is relatively small, and the force transmitted to the spindle is relatively large, so that the garbage can be easily crushed. And then combined with some interesting shape design can attract children's interest in playing. This is my design sketch. This is my draw from the top view.
So the fourth design will be the kids recycling bike. So this concept, the bike will be stationary, and when kids starts to pedal, it powers the attached recycling machine, so they can drop small recyclable items like bottle caps or plastic pieces into a slot at the top of machine, which is the crusher, the grinder. So the inside, the items get sorted and ground into small bits. So the ground up bits then come out of a chute at the front, where they can be collected in a small recycling bin. So this setup not only encourages physical activities but also teaches kids the importance of recycling.
Now I will continue with my design. So basically, the recycler mechanism goes at the end of the spring radius leg. There is a compressor designed to crush cans as heat ride it. When the rider moves forward and backward, the cans are compressed, making them easier for recycling facilities to process it. Other than that, there is also a support to ensure that the spring rider move forward and backward only, because as we know, spring rider can move freely according to the rider.
So I will brief shortly about this design. So this is a seesaw with a crushing mechanism. So when a seesaw moving up and down, so it will turn the connecting rod, and the crusher will move forward and backward to crush a waste. So to put a waste into the container, so the children will have to open the cover and also to collect the waste after it finish crushing.
So this is my design, which is a zip line. So to use it, the user can sit down on the platform while holding the handle and slide down through the with the zip line. So the cable above will move alternatively with the platform. This will produce kinetic energy due to their movement. This energy can be captured and converted into electrical energy using some mechanical systems. So many systems utilize a dynamo or small generator that is connected to the moving parts of the playground equipment. For example, as a child slides down a zip line, their motion can turn a rotor inside the dynamo. The dynamo converts the kinetic energy from the movement into electrical energy through electromagnetic induction. This process involves rotating a coil within a magnetic field which generates electricity.
Well, please look at this picture. From the feasibility point of view, all our design movements are very clear and visible. However, from the point of view of the complexity of the design structure, there are more second, third, and last design structures, and the price of materials required is relatively high. In terms of the materials used, the durability of the first three design and the last one is relatively high. But these designs use pulverized structures, or there is high-speed movement and some violent shaking. The risk will be greater. From the point of view of environmental protection, all the designs there are involved in resource recovery to some extent, so they are very environmentally friendly. The second and fifth designs have a large number of live examples for reference, so the reliability is better. Finally, in general, second, in addition to the security needs to be improved. Other aspects of performance is relatively good. So we choose design to add our final design.
After we have done the pure method before, there are two designs, which is design 2 and 5, that have the same rating. So we decided to move on to the next step by putting some weightage on the criteria. This will help us to choose the best design. We also use design 1 as our baseline. So as we can see, the total score for design 2 is slightly higher than design 5. The calculation was made and it assists us to decide that design 2 has the higher score than design 5. So by using this method, we continue our project by selecting design 2 as our final design.
Choice method is used to solve problems and innovate by providing a systematic approach to identify problems and generate solutions. There are 40 innovative ideas for choice method. The one that we choose to improve in the product is the asymmetry, in which we are going to improve it by adding a rail as a pathway for the tire to make sure that the tire and handle are not moving randomly. Secondly, for intermediary, we decided to use aluminium instead of steel as it is a lot more cheaper, but the strength comparison is the opposite.
After going through the view method and trace method, so we have decided to choose the design tool as our final design selection.
So now I will continue with project design specification for final design. So the main function is to use force from cycling to propel the crusher to recycle. So the client or market requirement is to spot safety and easy to operate. Next, performance requirement. So the load capacity is a children with weight from 20 kilogram to 40 kilogram. Operational force required at least 15 kilogram. Accuracy medium and durability. The design is 20 until 45 years. Next, for physical and operational characteristic. So the size is 4 meter in diameter. The weight is 30 kilogram. The material is composite material, aluminium transparent and polycarbonate. For ergonomic connection between bicycle and crusher to ensure efficient crushing process. Next, environmental consideration. So the operating temperature range is negative 20 degrees Celsius until 60 degrees Celsius, and the operating environment is we send out the outside weather. And lastly, for production and cost requirement, target production quantity is one for every playground in Malaysia, and the target cost for one design is 500 ringgit Malaysia.
Moving on to the next part is the safety requirements. We must put the seat belt to prevent accident, and the aesthetic and finish. The appearance must be attractive. The color is colorful and the texture must be glossy so we can easily attract kids or children. For the standards and regulation, we comply with ISO standards. For the testing requirements, prototype testing and load testing, 40 kilogram and 500 cycle, which is suitable for children. And next one is the market and competitor analysis. Target market, indoor and outdoor playground. For the competitors, is community engagement, because these systems encourage community involvement and education about renewable energy technologies. For the documentation and training, there is manual board for children to read to ensure proper use of this product, and also there's no training required. For the disposal and end of life, environmental impact, less rust forming and recyclability, because all materials can be recycled depending on their condition.
So what are the next steps? So the next step is the calculation, 3D design, and the simulation. So for the calculation, the dimension of the final design will be calculated, the calculation of the desired output, and also the efficiency of the final design. For the 3D design, we will draw the final design using SolidWorks software and assemble the parts to do the simulation of the design. And the simulation will be done by using ANSYS software.